मैं देख रहा था डिटेक्ट लूप इन लिंक लिस्ट. This one was easy. Given head. The head of a linked list determines the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be rechecked by the following the next pointer. Internally, pose is used to denote the index of the node that a tail's next pointer is connected to. Node the pause is not passed to the parameter. Return true if there is cycle in it, otherwise return false. Oh, these are due, and that is not good. ठीक है. Given head, the head of a linked list determine the linked list has a cycle in it. The head we have to determine करने का linked list में cycle है ना. The cycle in the list there is some node in the list that can be reached again by continuously following the next pointer. Internally, force is used to denote the index of the node that the tail pointer is connected to. Note that position is not passed as a parameter, return true. If there is cycle in the linked list, otherwise return false. Easy. यहाँ पे मेरे पास एलिमेंट है 3204 320 माइनस 4 और ये बोल रहा है इसमें साइकिल है तो रिटर्न करना ट्रू और साइकिल नहीं होगा तो रिटर्न करेंगे फॉल्स. साइकिल कैसे पता चलेगा कि इसमें साइकिल है या नहीं. साइकिल 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 अगर एक पॉइंटर के नेक्स्ट में किसी उस नोड का एड्रेस वेरिएबल है जो इटरेट हो चुका हुआ है. समझ लो यहाँ पे दिया ना 3204 3 के नेक्स्ट में 2 है 2 के नेक्स्ट में 0 है 0 के नेक्स्ट में -4 है -4 के नेक्स्ट में मान लेते हैं कि सेकंड जी सेकंड नोड है तो क्या होगा सेकंड नोड इटरेट होगा फिर नेक्स्ट आएगा फिर नेक्स्ट आएगा फिर नेक्स्ट आएगा तो इनफाइनाइट लूप चलता रहेगा जो इस लूप को प्रिंट करता रहेगा. तो यहाँ पे अगर है तो ट्रू करेंगे. यहाँ 1 2 है 1 के नेक्स्ट 2 को पॉइंट कर रहा है 2 का नेक्स्ट 1 का पॉइंट कर रहा है तो ये हमेशा बार बार चलता रहेगा. ट्रू है. यहाँ पे देयर इज वन एलिमेंट तो फॉल्स. ब्रूट फोर्स अप्रोच क्या होगा. ब्रूट फोर्स अप्रोच होगा कि हम एक हैश मैप रखेंगे. हैश मैप रखेंगे. हैश मैप में नोड रहेगा और आएगा इंटीजर मैप. हैश मैप में क्या करेंगे हैश मैप में अगर हम्म। फिर कुछ नहीं, एक टेम्परेरी नोड होगा, वो इटरेट होगा जब तक वो नल नहीं हो जाता। जब तक टाइम नल नहीं हो जाता तो क्या, जब तक टाइम नल नहीं हो जाता तब तक क्या, हम चेक करेंगे इफ मैप डॉट कंटेन्स की, और यहाँ पे टेम्प होगा। अगर ये हुआ तो क्या होगा, अगर मैप डॉट कंटेंट्स की टेम्प अगर कंटेंट्स कर रहा है तो हम रिटर्न करेंगे ट्रू, रिटर्न करेंगे ट्रू ना, मतलब हम इटरेट कर चुके हैं और उस मैप में फिर से आ रहे हैं, तो ट्रू करेंगे कि यस दिस लिंक लिस्ट हैज साइकिल इन इट। नहीं तो एल्स में क्या हो जाएगा, नहीं तो क्या होगा, मैप में पुट करेंगे टेम्प नोड कॉमा 1, और मेरा टेम्प जो है टेम्प डॉट नेक्स्ट हो जाएगा, बाहर आके रिटर्न फॉल्स। ये है ब्रूट अप्रोच होगा। इस टाइम कॉम्प्लेक्सिटी सारे एक बार इटरेट कर रहे हैं, ऑर्डर ऑफ एन, स्पेस कॉम्प्लेक्सिटी ऑर्डर ऑफ एन, क्योंकि हम सारे एलिमेंट को स्टोर कर रहे हैं। इसको ऑप्टिमाइज यहाँ पे ब्ला 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 दिया हुआ है, ये हुआ 15 में से 4 गए, 15 से 4 गए, 14 से 13 गए, 6 गए, 7 गए, 8 गए, 9 गए। 9 जो टेल है वो फिर 15 को कनेक्ट कर रहा है, तो हम फिर 15 पे आ गए, फिर ये लूप चलता रहेगा चलता रहेगा चलता रहेगा, हैश मैप तो सॉल्व हो जाएगा। हैश मैप इंसर्शन कॉम्प्लेक्सिटी, हैश मैप यहाँ पे टाइम कॉम्प्लेक्सिटी ऑर्डर ऑफ एन सबको इटरेट करने के लिए, पुट करने के लिए ऑर्डर ऑफ लॉग एन, सर्च के लिए ऑर्डर ऑफ log n is equals to order of n plus order of n ऑर्डर ऑफ n दो बार ऑर्डर ऑफ log n यूज होगा, एक बार इंसर्शन के लिए, एक बार सर्च करने के लिए। पहले कंटेंट चेक करेगा, नहीं तो पुट करेगा। ये हो जाएगा ओवरऑल टाइम कॉम्प्लेक्सिटी। कॉम्प्लेक्सिटी और ऑप्शन हुआ क्योंकि हम हैश में पुट करें। कोड यहाँ लिख दिया था, हैश मैप बनाया, लिस्ट नोड है, temp इज नॉट इक्वल टू नल, चेक कर रहे हैं, पुट किया, temp डॉट नेक्स्ट होगा। एक्सेप्ट हो गया। एक दूसरे को हम छोड़ना। ये तो हो गया। रूट अप्रोच हमने देखा है ऑप्टिमल अप्रोच द प्रीवियस मेथड यूज्ड the order of an additional memory which can become quite large as the linked list length grows. It has to be the total algorithm is introduced is an optimization. सबसे पहले तो टोटवाइजन हेयर एल्गोरिथम क्या था? टोटवाइजन हेयर एल्गोरिथम था हम दो पॉइंटर इनिशियलाइज करेंगे दो पॉइंटर पास पॉइंटर दो पॉइंटर इंक्रीमेंट होगा +1 से पास्ट पॉइंटर इंक्रीमेंट होगा +2 से सपोज मेरे पास 1 है 2 है 3 है 4 है 5 है 6 जब हमारा स्लो पॉइंटर यहाँ पे होगा पास्ट पॉइंटर यहाँ पे होगा फिर स्लो पॉइंटर +1 होकर यहाँ पे आएगा पास्ट पॉइंटर यहाँ पे आएगा फिर स्लो पॉइंटर यहाँ पे आएगा पास्ट पॉइंटर यहाँ पे आएगा फिर स्लो पॉइंटर यहाँ पे आएगा पास्ट पॉइंटर यहाँ पे आएगा तो ये बोलता है टोटल हेल एल्गोरिथम जब एफ जो होगा फास्ट पॉइंटर उस पॉइंट को करेगा फास्ट पॉइंटर जब तक जब नल हो जाएगा तो स्लो पॉइंटर हमारे मिडिल ऑफ द लिंक लिस्ट होगा साहिबा मैं लेने आया हूँ तेरी कमर The total algorithm is a fluid circuit detection algorithm is a pointer algorithm that uses two pointers moving at different speed to solve certain types of problem in the linked list or arrays. The algorithm is named after Aesop's fable of the tortoise and the hare because one pointer the hare moves twice as fast as the slow pointer. Slow, yeah, tortoise hare algorithm. ख्वाहिश तो ख्वाहिश है तो tortoise hare algorithm क्या था दो पॉइंटर होंगे अरे यार ट्यूटोरियल है एल्गोरिथम क्या बोलता है कि हमें 2 पॉइंटर इनिशियलाइज करना है, जो फास्ट स्लो पॉइंटर फास्ट पॉइंटर। जो फास्ट पॉइंटर होगा वो 2x स्पीड से दौड़ेगा स्लो पॉइंटर के स्लो पॉइंटर की कंपैरिजन में। स्लो पॉइंटर हमेशा 1x, मतलब स्लो पॉइंटर +1 से बढ़ेगा, फास्ट पॉइंटर +2 से बढ़ेगा। ठीक है, इसको यूज करके हम साइकिल फाइंड कर सकते हैं या मिडल ऑफ द लिंक भी फाइंड कर सकते हैं। If there is no loop, when the tortoise and hare enter the loop, they might be at different position within the loop due to the difference in their speeds. The hare is moving faster, so it will traverse a greater distance same amount of time. If there is no loop in the link state, the hare will eventually reach the end and the algorithm will terminate without a meeting event. When the linked list length is odd. स्लो पॉइंटर यहाँ पे है, स्लो पॉइंटर यहाँ पे, फास्ट पॉइंटर भी यहाँ पे है। स्लो पॉइंटर 1 बढ़ेगा, फास्ट पॉइंटर 2 जाएगा। स्लो पॉइंटर जब 3 पे आएगा, फास्ट पॉइंटर 5। द फास्ट पॉइंटर has reached the end of the linked list as a fast dot next is null, hence false as there is no cycle. When the linked list length is even. Slow fast, slow fast, slow fast, slow fast null पे आएगा। Fast pointer become null since we return false as there is no cycle। ठीक है। Initialize 2 pointers slow and fast to the head of the linked list. Slow will advance 1 step at a time, fast will advance 2 steps at a time. These pointers will move simultaneously. कहाँ थे हम? ट्रेवर्स करेंगे फास्टर फास्टर। मेरे पास 1 2 3 4 5 6 है। स्लो यहाँ पे है, फास्ट यहाँ पे है, स्लो यहाँ पे आ गया, फास्ट यहाँ पे आ गया, स्लो यहाँ पे आ गया, फास्ट यहाँ पे आ गया, स्लो फास्ट यहाँ पे, स्लो यहाँ पे है, फास्ट यहाँ पे है, स्लो यहाँ पे है, फास्ट यहाँ पे है, स्लो यहाँ पे है, फास्ट यहाँ पे है, फास्ट डॉट नेक्स्ट अगर 3 को पॉइंट करता है या 2 को, पता कैसे चला?
So let's continue the playlist. Before that, hey welcome back to the channel. I hope you guys are doing extremely well. So the problem that we will be solving today is detecting a loop in a given linked list. So what is the problem stating? It is stating that you'll be given the head of a linked list. Yes, you'll be given the head of a linked list and you'll have to return me true if there is a loop in that given linked list. So what is the definition of a loop when it comes to linked list? And the definition is if there exists a minimum of one node where you start and you reach back, then we can say that the linked list has a loop. Let me explain you. If I start at 4 and I move ahead, I'll be reaching back to 4. I'll be reaching back to 4. So I'm sure that there is a minimum of one node where I can start and reach back. And if there does exist a minimum of one node, I can say that there is a loop, and in that case I'll be returning true. Got it? Now over here there are multiple nodes, 3, 4, 5, 6, 7, 8, 9. If you start from any of them, you will reach back. But if you start from one, you will never reach back one. So that is why I'm saying a minimum of one node is required. What if this problem comes up in an interview? We will be starting off with the extreme naive solution. And what will be that? What are we looking for? We are saying that in case there is a minimum of one node where you start and you reach back, that means it is visited more than once. It is visited more than once. I'll have to remember somehow that I've seen it previously, because when I'm traversing, I need to remember that I had seen 5 previously, and that is when I reach back 5, I'll know, hey, I did see this node previously, and that is what will tell me that, hey, there is one node minimum which has been seen twice. And if it has been seen twice, it means that you're on a loop. So which data structure to use to remember these things? Yeah, you're correct. We'll be using the concept of hashing. So what we will do is, again, we will not tamper head, we will take temporary, and we will take a map data structure. So let's take a map data structure. And what we will do is, this map data structure will be of the type node. Node will be the key, and integer or boolean. So basically the node will be the key, and integer 1 or boolean true will tell me if I saw that, or integer 0 will tell me that I haven't seen it. So what we do is, we start with the temporary, which is the node 1. So we keep the node 1 and we say I have seen it. Perfect. Let's move the temporary to the next. Goes to 2. I'll store 2 and say I've seen it. Goes to 3. I'll store 3 and I'll move ahead. Goes to 4. I'll store 4 and move ahead. Goes to 5. Remember, you store the entire node, not the values. Not the values, because it might happen the values might repeat in the node. The values might repeat in the node. So do not store the values. Store the entire node, entire object in itself. Okay. So 5 stored. Let's move to 6. 6 stored. Let's move to 7. 7 stored. Let's move to 8. 8 stored. Let's move to 9. 9 stored. And the moment we move back to 3, what you do always is, before storing it, just a small step. Before storing it, just introduce a small step to check if this 3 that you're currently at, is it in the map? And you can see that there's a node with 3. There's a node, exact same node. I'm not considering the values. I'll be comparing the object. Is it the same memory location? He says yes, it is the same memory location. It is pointing to the same memory location. If it is, I can say that I've encountered a loop and I will stop. So this is what we can do. Like, we can simply use hashing. So if I have to write down the code, can I say I'll be requiring a map data structure which will be storing the node in Java, node star in C++, int, and a map. Again, I'll be writing the pseudo code. You can find out the C++, Java, Python, JavaScript codes in the description below. So this is how we start off with. Right after that, what is the next step? I know I need a temporary which points to head, because usually we do not tamper head. So we will take the head to temporary and we will start moving. We will say temporary not null. Perfect. And we need to insert it into the head. But I did tell you, before inserting, have a check. So you say, hey map, find, or whatever is your function, depending on whatever language you're using, just look at the map. So you can say look in the map. So it can be find, it can be search, depending on your language. Find this particular node temporary. If you can find it, it means it is there, and you say, hey, return true. Return true means it's a loop. Or else you say map, can you put, in Java it is put, in C++ you can straight away say temporary equal to 1. In Java you can write mpp.put and you can put this value temp comma 1. That is your choice how you want to do. Once you put it into the map, let's traverse to the next, which is temp equal to temp next. And understand one thing, why have I written not equal to null? Because if I had a linear data structure, temp would have started from here, gone here, stored everything into the map, and then at the end it would have ended at null. The moment it would have ended at null, the while will be done and I can straight away return false, stating there is no loop. Got it? That is why it's very important to have a check for null, because it might not happen, like there might not be a loop. So what about the time complexity? Can I say I'm traversing the entire linked list? I am. And at the same time, I have a couple of map operations. If you carefully see, one is inserting into the map, the other is checking in the map. So there are two map operations. So depending on if your map takes logarithmic, right, depending on whatever your map takes, it will be 2 into log of n or 2 into 1 if your map is a big of 1 time complexity. I've already discussed the time complexity of maps in the hashing lecture. Please go back and watch it, you'll understand this. So depending on your language, your map's time complexity, you can determine that. And what about the space complexity? I'm storing all the nodes in the map. So big O of n, because no matter what you do, you will end up storing all the nodes. That is something which will happen for sure. So this is the time complexity and the space complexity. This is where the interviewer will not be happy with the extra space that you're using and he'll ask you to optimize it. So the optimal approach will be using the tortoise and the hare algorithm. In case you're not aware of this, please go back and watch out the lecture finding the middle of the linked list, because that is where I've discussed this algorithm, the slow and the fast pointer algorithm, which is basically the tortoise and the hare algorithm. So in this particular algorithm, we take couple of pointers, slow and the fast pointer. Slow will be moving by 1 step, the fast pointer will be moving by 2 step, and they will be moving simultaneously together. So what we do is, we're given the head of the linked list, right? So we will take 2 pointers, slow and the fast pointer, and we will try to move them simultaneously, one by one, the other by 2. So let's start. Slow and fast, let's move them together. Slow as we said by 1, fast as we said by 2. That's the first step. 1, 2, done. Let's do the next step. Again slow and fast will move by 1 and 1. So slow will reach here and the fast will reach here. So this is where they reach. I'll be raising this so that it has more clarity. In the next step, again they'll be moving 2 steps. So the fast pointer will reach here and the slow pointer will reach here. So this is how it moves step by step. In the next step, again they will be moving 2 steps. So the fast pointer will reach here and the slow pointer will reach here. So this is how it will look like. Perfect. In the next step, again move them by 1 and 2. So slow will be here and the fast pointer will be somewhere here, because 2 steps, it doesn't go like